of the embedded system. So this classification is based on the generation or the complexity and performance, then the behavior of the system, whether it is deterministic or non-deterministic, and then depends upon the triggering. So we have seen such classification, and after that we have also seen the purpose of embedded system, for which every embedded system is designed for different functions, okay, and the different application. So for which purpose the system is designed, so according to that, here we can classify the embedded system. So in this classification, or in this separation, we have seen that there are different purposes for designing the embedded system, in which when the first one we have seen as the data collection, storage, and representation. So where the data only will get taken or received from the external world, okay, then either it will be stored, or it will be represented, or it will be shown, provided to the other peripherals or other system. Then we have seen the system which is designed for the data communication. So where the data which is coming from one device that will get communicated to the other devices, or from, just like we have taken the example of satellite and DTH system. So where the data will get communicated from one system to the another system. So for that purpose also the embedded system is designed. So here the data communication may be wired or wireless. So if it is wired communication, we have the RS-232, or also we have seen the networking. Okay, so some and in the wireless we have seen the Wi-Fi or Zigbee. So these are the different communication technologies which is imparted into the embedded system. After that, we have seen also the embedded system is also having the purpose of data processing. So where the data which is coming from the external world, that will get received by the system, and then it will get processed by that particular system. So from the external world, the data may be text, maybe video, maybe image, maybe analog signal. Okay, so whatever the data is coming, if it is analog, that will first get converted into the binary equivalent by means of using analog to digital converter, and then it is transferred, or it is provided to the embedded system, and the embedded system will process the data so that the desired output, or the required output, will get provided by the embedded system. Okay. Then some of the embedded systems are designed for only for the monitoring purpose. So we have seen the example of healthcare applications or healthcare instruments, where only the embedded system is designed where the data or the input which is coming from the sensors, or from the input side, that will get only monitored, or it will only get represented. Okay, so there will be no any sort of modification in the data, but whatever the data which is coming, that will get represented by the system. So for just monitoring purpose also the embedded system is designed. Okay. Then also we have seen some of the embedded system is designed for controlling purpose. So just like industry automation, where the external the data which is taken from the external environment, according to that, the reactive response will be provided by the embedded system. So the actuators will be driven, or the other peripherals will get driven by the embedded system to control a specific area or a specific unit. Okay, so we have also seen the example for the air conditioners also. So where from the external and temperature that is sensed, so according to that, the actuators will be turned on or turned off, or the cooling system will get turned on or turned off. Okay, so that the external environment or the external temperature will get controlled. Okay, then also we have seen some of the embedded systems are designed for an application specific. Okay. Just 1 minute. Okay. Okay, sorry for the disturbance. So what we have seen the different application-specific instruments are also designed uh, by the embedded system. So if that particular application is different from others, then according to that, or that user, according to the application specific user interfaces, here the systems are designed just like a smartphone where the that specific any one system, it requires an application. Okay, so in the smartphone, it has made some sort of modification in the system. Okay, so this is depending upon the application. For example, even we can take the example of the graphic cards, so which will work only for some graphical representative for graphical applications. Okay, so where that particular embedded systems will get designed depending upon that particular application. Then we have seen the characteristics and the quality, characteristics of the embedded system. Now, if we take any embedded system, whether it is the embedded or non-embedded, non-embedded means where the processors are not available or more hardware is not available. So, in any sort of system, here it will have two aspects. One will be the functional aspects and one will be the non-functional aspects. So functional aspects means depending upon the functionality of that particular system, whether it is working properly or not. Okay, and there are some non-functional aspects are also available. That is called as the quality attributes of that particular system. Okay, now if you design any sort of system, then both this functionality as well as non-functionality, both these will get considered for designing that embedded system. So in this functionality aspects are also called as the characteristics of the embedded system. So in these characteristics, we have seen some characteristics which are available or which are required for designing the embedded system. First one we have seen as the application or domain specific. So we can call it as application and domain specific characteristics. Okay. So in this domain specific application and domain specific characteristics, we have seen that if any application is need to be designed. Okay. So every embedded system is having certain functions to perform. Okay, and that particular system is intended only for that specific function or intended to that specific function. Okay, so if any one system is designed for any one application or any function, then it cannot be used or cannot be utilized for other functions or other applications. Okay. So here the characteristics which for which that particular application is designed, okay, or embedded system is designed. So that depends upon only the requirements of that particular applications. Okay, so this is one of the characteristics. The second characteristics we have seen as the reactive and real-time response of the system. So here in this reactive and real-time system, we have seen that every system or every embedded system which we are designing for a specific application is communicating with the external world. Okay. That means the sensor is receiving the data from that external world, and according to that data here, the user-defined input will get converted. That means whatever the input is available, that will get converted into the binary equivalent. Okay, and then it is provided to the input port of the system. Okay, now if any changes which is created or which is done into the external environment, that will get captured into this system, or that will get captured into the embedded system, and after capturing the data, it will provide that data to the embedded system. Okay, now if such changes are occurred, then this control algorithm or the program which is available into that embedded system, it reacts on that particular system or reacts on the particular input and provides the data, okay, or provides the output variable to a desired level. Okay, so here whatever the reaction which is provided by the embedded system, either it will be depends upon the input environment, or as well as it will be depend upon the output which is provided by that particular embedded system. So even we can call it as the causal system. That means the feedback systems also, where the response from the input will get change in the which will make the change into the output. Now here, if suppose this response or this change into the output, that will be or that if, that is depends upon the external environment or external changes. Now whatever the external changes takes place, that may be the periodic changes or that may be non-periodic changes. That means the event will occur within a specific stipulated time, or there will be a sudden change in the environment or sudden change into the input provided by the sensor. Okay. So if it is periodic, then it is called as the real-time change, and if it is non-periodic, then it is called as the general purpose operating system, or it will work with the general purpose systems also. Okay, so here, if the time constraints are more, then in such embedded systems, here the real-time operating systems are required, or real-time operating systems are used. And if the time constraints are not that much of critical, then the general purpose operating systems are used into the embedded system. Okay. So after that, we have also seen that the environment in which the embedded system works. So here we can call it as the environment, okay, or operational environment. Okay. So in these operational environments, if suppose the system is deployed into the environment which is very dusty, or having very high temperature, or very low temperature. Okay, so in that case also, if the embedded system needs to work properly, so depending upon the temperature or depending upon the external harsh environment, if suppose the system is withstanding, or system needs to withstand properly, so that it should not affected by, or the output of the embedded system should not affected by that particular adverse environment. Okay. So during the design of the embedded system, the operator or the user needs to take care of the condition of the operating. The user needs to, or the needs to take care for the operating condition in which that particular embedded system is working. Either it is in the high temperature zone, or dusty zone, or low temperature zone, and so on. Okay. So here the user should not compromise with the cost, or should not compromise with the quality of the particular system. Okay. So here there may be the problem of the power fluctuations, there may be the problem of corrosion, there may be the problem of aging, there may be the problem of heat dissipation, and so on. So here the user, while designing the embedded system, the user should not consider the cost and the quality attributes for the particular embedded system. After that, we have seen the one more characteristics, that is the distributed embedded system. Okay, so if suppose any embedded system is designed, that there may be possibility that there will be a large embedded system which is having more number of or many number of small embedded systems, okay, which are combined together, and which will make a large embedded unit. Okay, so for even we have seen the example of automatic vending machine, okay, where the data which is taken from all the vending machines together, and then it will get processed. Okay, so here every vending machine or every embedded system will be the independent embedded system. Okay, and they will work together, okay, to make the large embedded system. Okay, then also we have seen one more characteristics, that is the small size and weight. Okay, so while designing the embedded system, the user needs to consider the size and weight of the embedded system also. Okay, so it is called as the product aesthetics. Okay, for example, if we want to buy a new mobile, okay, then we are considering the comparative study of different mobiles, okay, with the different pros and cons of the products which are available, or the mobiles which are available. Okay, so we are considering during the selection of mobile, we are considering the size, weight, shape, style, okay, etc. Okay, so while considering the performance of the smartphone, also we are considering these different aspects also. Okay, so also, while designing the embedded system, here we need to also consider that the system should be smaller, beautiful, as well as the weight of the system should be less. Okay. Then also we have seen one more characteristic, that is the power concerns of the embedded system or power consumption of the embedded system. So some embedded system requires more power, or so here we need to design the embedded system in such a way that it should minimize the heat dissipation, or it should minimize the power consumption. Okay. So if suppose the system is working with low power, okay, then that particular system will be accepted by the different consumers, okay, because the power consumption will be low. Even if we take smartphones, here also we are considering the power consumption. Okay, so we are saying we are considering the battery capacity as well as the power consumption which is done by that particular mobile. Okay, so if the power consumption is more, there will be the battery life will be less, and if the power consumption is less, there will be more battery life. Okay, so we are also considering such different characteristics of the embedded system while we select the particular embedded system, or if we select a specific devices. Okay, so these are the different characteristics of the embedded system. Now, if we consider about the non-functionality or functionality attributes of the embedded system, then it is called as the quality attributes of the system. Now, here these quality attributes are either operational or non-operational. So here first we will see the quality attributes. So these quality attributes are non-functional requirements that needs to be documented properly. So these quality attributes are non-functional requirements of the embedded system. Okay, so whatever the characteristics which we have seen previously, these are the functional requirements of the embedded system. So when embedded system is working in any environment, or when that particular embedded system is functional, so in that case we have to consider these different characteristics. Now, if we want to consider the non-functional requirements of the embedded system, then that are called as the quality attributes of that particular embedded system. So if these quality attributes are more concrete or measurable, then it will give the positive impact on the system development. Okay. And also it will provide a better end product. So various quality attributes we need to address for designing and development of embedded system. So so here for designing any embedded system, there will be two attributes. One attribute is called as operational attributes. Operational attributes, and another one is called as the non-operational attributes. Okay, so one will be operational and another one will be non-operational attributes, and these all should be documented properly so that the end product during the product development cycle should be more rigid, and that particular system there will be the positive impact on this particular system development. Okay, so first we will see what are the operational attributes. Okay, operational attributes. Okay, so in this operational attributes, the first attribute is the response of the system. So what is the meaning of a response? It means the quickness of the system. Okay, that means how much quick the particular system will respond the input. Okay, so if the system is very much fast to track the changes in the input variables, then that system will be more responsive. Okay, so most of the system demands that fast response. Okay, which is in the real time. Okay, so for example, if we take the system of flight deployment, um, or even if we take the example of the satellite launching system. Okay, so if suppose here the response is slower, then it will damage the safety of that particular system or safety of that particular application also. Okay, so there should be the system should be more provide fast response for which it is designed. But it is not necessary that all the systems should be that much of fast or that much of responsive. But the if suppose the system is designed for real-time applications, okay, or for real-time response, then that response time requirement should be less. Okay, but if we take the example of the system which is designed for simple applications, just like games or just like toys, etc. Okay, so in that case, here the response is not that much of matters. But where the real-time applications are available, in that case, here the response of that particular system should be faster. Okay, that means the time consumption for processing the data should be less. Okay, so that will be the first operational attribute. The second professional attribute is the throughput. Now, what is the meaning of throughput? It is nothing but the efficiency of the system. So we can define this efficiency in terms of the rate of production or the rate of operation of the defined process. Okay, so for which that particular embedded system is designed. Okay, now if suppose if any one product XYZ product that needs to be designed or that needs to be manufactured using the embedded system. Now, how much number of products are designed by that particular embedded system within a stipulated time, okay, or with respect to time, okay, or within that specific period of time. If suppose this rate of production is more, then the system will have more throughput, okay, or system will have higher efficiency. But if this product development is requiring or the number of products which are developed within a time or within a stipulated time is less, then it will have the low efficiency. Okay, so the rate of that production, if that is expressed in terms of units of products or like batches, okay, or other measurements. So in that case, here the rate should be higher. Okay, then we can say that the particular embedded system is having the high throughput. Then the next operational attribute is the reliability of the system. What does it means here? This reliability, we can say that how much in terms of percentage, if we consider how much in terms of percentage we can rely on for the proper sorry. So in any embedded system, we are using that particular embedded. Okay, just 5 minutes, please. Okay, sorry for the inconvenience. So where was so we are considering the reliability of the system. Okay. When we are considering the reliability, what does it mean? That if we are designing any system, okay, then for proper function of that particular system, how much we rely on that system, or how much percentage we can consider that system will work properly. Okay, that is called as the reliability of the system. Okay, or even we can call it as in how much percent there may be the susceptibility of that particular system failure. If the system is more reliable, that means it will work more faster, as well as it will work with proper. It will provide the proper functioning of that particular system. Then the next quality attribute is the maintainability of the system. Maintainability of the particular system. So this maintainability deals with the support and the maintenance which is provided to the end user by the client. Okay. So in case of the technical issues, or in case of the product failure, or in the or on the basis of routine checkup, here both these reliability as well as the maintainability both are considered. Okay, and these two are complementary disciplines. That means if suppose the reliability is more, the maintainability will be less, and if the maintainability is more, the reliability will be less. Okay, so both these are complementary cases. Okay, if the system is more reliable, okay, or we can say that if the reliability of the system is increases, there may be the less chances of the system to get failure, okay, or there will non-functionality of the system will get reduces. Okay, so the need for maintainability is the need of this maintainability is closely related to the system availability. Okay, and this maintainability can be broadly classified into two categories. One is the scheduled or the periodic maintenance system, or periodic maintenance provided to the particular embedded system, and second is maintenance provided to the unexpected failure. So there will be you might have studied about the annual maintenance. So if I have any system, then the system provider or the vendor is providing the annual maintenance of the system. Okay, so that is called as the periodic maintainability. Okay, and if there is any unexpected failure in the system, then if the maintenance are provided, then it is called as the maintenance to the unexpected failures. So the consumer embedded system, or consumable embedded systems which are designed for consumable products. Okay, so there will there will be sorry. So if we take any sort of embedded systems, then that particular embedded system may have certain components, okay, which may get wear and tear, and also it will affect the output of that particular system, that will get affected due to the due to some of the wear and tear, and that should be replaced periodically. That means after 1 year or after 2 years and so on. So the maintenance which is provided for such cases, it is called as the periodic maintenance. Okay, and in some cases here there will be unexpected failure in the system. So due to the firmware, or due to some of the failure into the hardware of the system or components of the system, here that particular maintenance should be is for the unexpected failures. So in both of these maintenances, here either the vendor needs to provide the support either by offline or by online, okay, or in any cases. So if that maintainability is available, or that particular support is available, then the end user will accept that particular system properly, or more number of end users will accept that particular system. So maintainability should be also considered for the operational quality attributes. Okay. Then the next which we need to consider for as a quality attribute is the security of the system. Okay. Now here, this security is considered for the confidentiality of the end user. That means the data which is available into that particular system, or the information which is available in that particular system, should be confidently deals with the production or the application, okay, of that particular embedded system, and should not respond to the unauthorized access or unauthorized disclosures. Okay, so here whatever the available data which is available, or the information available into that particular system, should be protected properly. Okay, so in terms of the application as well as in terms of the information also, in both the cases, that particular system should get protected or should get secured from the unauthorized access. So this security is also needs to be considered while designing the embedded system. Okay. Now the next criteria is the safety of the system. Now you might get confused with the security as well as the safety. Okay, the security is concerning with the information, and safety is concerned with the possible damages that can happen either to the operator of that particular embedded system or to the application for which the embedded system is designed. Okay, so here the safety concerns with to avoid the possible damages that can happen to either operator or to the public or to the environment or to the application. Okay, so here if suppose any breakdown happens in the embedded system, it will cause some sort of adverse effect, just like the emission of radioactive or hazardous material from that particular embedded system, or from that particular operational area where that particular embedded system is available. Okay, so if suppose the breakdown of that particular embedded system is happened due to the hardware failure or the firmware failure, then the particular safety analysis of that particular product or that particular product engineering needs to be evaluated, and then that particular damage or should be get determined properly, and that can be that particular damage should be acceptable one. That means that much of acceptable level that damage can happen, and the system should provide the safety up to that much of acceptable damage. Okay, now some of the threats that particular embedded system should be done, like if suppose any damage happens, then the system should get break down properly, or there may be the system should go into the power down mode or into the sleep mode. Okay, so that there should not be more damage to that particular application or more damage to that particular environment. So this safety is also needs to be considered for designing the embedded system. So these are the quality attributes which are the operational one. Then that means here during the operation of that particular embedded system, or when it works into a certain field, then these quality attributes are considered. Okay. Now there are some more quality attributes are also considered which are non-operational. Okay. That means if before the operational aspects, or before implementing the system to some of the application field, before that some of the non-operational basics or the aspects also needs to be considered. Okay, And these characteristics are categorized like this. So first, these are the non-operational quality attributes. So in which the first one is testability and debug ability. So what does it mean? So this testability deals with how easily one can or the user can test that particular device, okay, or can test the particular design. Okay, so this testability considers with the hardware as well as the software also, or hardware and firmware also, for both the cases. So this testability should be more. That means the end user or any user can test that particular device or particular embedded system in terms of the hardware as well as in terms of firmware very easily. Okay, and in that in the desired manner. Okay, so if the testing is in the desired manner, the system will is working correct. If the testing is not proper or there will be the failure in the system, then that particular system needs to be redesigned. Okay, so these are the testability. And what about the debug ability? So debugging, what does it mean? If suppose we are designing or we are designing an embedded system, and when we debug that particular system, okay, then after debugging, here there will be some of the probable sources where we are getting the errors. Okay, so to figure out that particular errors, where that particular errors are occurred, and which will create the unexpected behavior of the system. Okay, so that can be identified very easily, okay, or that should be identified very easily. Okay, so here while designing the particular embedded system, here we need to consider how easily we can test the particular system and we can debug the particular system, so that if there are any errors which are occurring into that system, that can be easily identified and can be remodified or restructured. Okay, the second characteristics which are non-operational is the evaluability of the system. Evolvability of the system. So here this term is also referred as non-heritable heritable variations. Okay, that means here if we are designing any embedded system, then how easily we can convert that embedded system to the modified system without making any sort of damage of the system, but by taking the advantages of the firmware and the hardware technology. That is called as the evaluability of the system. Okay, have you understood it? The meaning is, if suppose we have designed one embedded system, okay, so this is the first embedded system which is designed. Okay, now due to the changes in the product or changes in the external environment, we want to make some sort of modification in the system. Okay, or there may be possibility that the product which is designed previously will have more application specific advantages or upgraded hardware and software is available. Okay, then how easily we can make the changes into this embedded system or this system which is designed previously, okay, without making any sort of damage to that particular product or without making damage to that particular application. How we can modify that particular system, okay, either by introducing the new firmware or by introducing the new hardware. That is called as the evolvability of that particular system. Okay. Now the next one is the portability of the system. So this portability is also called as the system independence. That means if we say we have seen the general purpose computing system, if we are using that computing system for one particular application, and if we want to change that application, or if we want to use the same embedded system for computing system for any other applications, that can be easily done into the general purpose computing system. But embedded systems are designed for a specific application only. Now, if suppose if that particular embedded system is capable of functioning into the various environments or into the various applications, then it is called as the portability of the system. That means here, whatever the target which is, or we can say, what are the output target of that particular application, if it is changed, then that particular system should work properly, either by making any sort of changes into the particular microprocessors or controllers, or by making changes into the particular firmware or the software which is available into that particular system. Okay. Now, even if suppose the same processors and controllers and same firmwares are available, then also the system should be more portable, that the software that can be get easily upgraded, or the operating system that will get more easily upgraded. Okay, or the same firmware can be used into the different embedded systems. So these are called as the portability attributes of that particular embedded system. For example, if we take the firmware, it is designed, or embedded system is designed where the program is written into the embedded C. So only by changing the processor family, or by changing the processor company, we can use, or we can implement the same program or same software for different applications or for different embedded systems. But if we take the example of the assembly language, then assembly language, here every specific processor will have its set of instruction, and that will work on its own assembly language only. Okay, or on processor only. So here the portability will not be possible, but that same portability is possible with the embedded C. Even if we take the example of the software, then the softwares which are designed by the Microsoft, just like Microsoft Visual C and so on, then that particular software is running only on the Microsoft platform. Okay. But if we take the systems or the applications which are developed by Java, then that will work on any platform. So this is called as the portability into the operating system, or portability into the software also. Okay, so that is also needs to be considered during the design of that particular embedded system. Okay. Now, the next point is, or the next characteristics or quality attribute is time to prototype market. Okay. Time to prototype and market. Now, what does it mean? Here, if suppose you are designing any sort of embedded system for a specific application, then the time required for the designing of that particular concept, and also to design the prototype of that particular concept. Okay, so if that time required is more, then it will affect the market. Okay, that means here other competitors or other vendors can design the same embedded system within a less time as required by the one user, or as required by you. Then it can be easily available into the market as before you, so that the market will get more captured by that particular vendor. Okay, so the time required for designing the prototype and time required to market that particular prototype, or market that particular products, that also needs to be considered during the design of any sort of embedded system. Okay. So whenever any vendor is designing any particular embedded system, it consumes its time as well as its cost for designing the prototype. But if that particular prototype is not available, or if that product is not available in the market within a stipulated time, or within if it is required more time, then the particular vendor will have to bear huge losses due to the other competitors which are working in that market, or which are available into the market. That will these other vendors will design the embedded system more by taking less time as compared to the you. Okay. So here, while designing any embedded system, the time required for designing of that particular embedded system also needs to be considered for before the designing of that particular embedded system. Then also the vendor or the user needs to consider the per unit cost and revenue. Cost and revenue. Now see here, every vendor who is designing that particular embedded system or designing any sort of application, then here that particular vendor is designing that particular system to generate the profit or to generate the revenue. So here, to generate the revenue, that product should be marketed faster, that should be sell more as compared to the other ones. And for selling that particular product, here the per unit cost required for designing that particular product should be less. Okay. So initially, when the vendor is designing prototype, the per unit cost or the cost for designing the prototype will be more. Okay. After that, the cost required for the introduction of the product, that will be more. But once there will be more growth or more number of units are produced by the particular vendor, then the cost required for designing the embedded system or per unit cost for that particular embedded system will go on reducing. Okay. And here the revenue which is generated by that particular vendor, that depends upon the number of units that will be sold or that will get sold into the market. So here that also needs to be considered by the vendor while designing the embedded system. So here, for every per unit cost, how much cost is required, or if suppose this cost is lesser, then the product will be cheap and more number of users or more number of end users will purchase that particular product. Okay, so if we take the example of smartphones, when we are considering the cost, when we are choosing the smartphones, first we are considering the different what do we say, the specifications of the smartphones. At the same time, also we are considering the cost or the price of that cell phone. So if the price is less, then the product will be more purchased by the end users. So here, to reduce the price, first the price required or the cost required for designing that particular embedded system should be less. Okay. So here the vendor should also consider the cost required for designing or for production of the units of the embedded system, and also needs to consider the revenue which is generated by that particular by selling the particular embedded systems or by selling the products. So if there is more revenue, the vendor will produce more products. But if the revenue is less, the vendor will not manufacture or will not produce the products. So here the per unit cost and revenue also needs to be considered while designing any sort of embedded system. So these are the non-functional quality attributes of the embedded system. So while designing the embedded system, we need to consider the functional as well as non-functional quality attributes also. Okay. So this is all about the basics of embedded system. Any queries? कोणाला काही क्युरीज आहेत का? अरे पण समजते तर का मी जे काही सांगतो ते? तर फक्त टर्न ऑन करायचं, मीटिंग अटेंड चालू करायचं आणि पुन्हा म्यूट करून ठेवायचं बाजूला, असं काय आहे का?